Hey, what's up, guys? This is Chung, and so this time I want to talk about this problem, 1032 stream of characters. Actually, this problem is today's daily challenge, and actually, it's kind of rare to see a hard problem in a daily challenge. That's why I decided to talk about this problem with you guys. You know, so this is like a small system design problem. Basically, it asks you to implement the stream checker class as follows. Okay, so the stream checker class, the constructor initiates the data structure with a given list of words. Okay, and the query letter returns true if and only if for some k is greater than one, the last k characters queried in the order of oldest to the newest. Okay, basically we need to query from the last one to the earliest one. It's a reverse order, including the letter just queried spell one of the words in the given list. For example, right, this one. We have a words list here, CD, F, and KL. And then the first time we try to query A, obviously there's no word with A. How about the B here? Nothing, nothing here B, because B, when we have B here, not only we need to check B, but we also need to check B and A. Okay. And now the third one is C. So is there any word starting with C? Yes. Uh, yes. So C and D. Okay. And the last one. So now it's D and C. Okay. So when we have a D and C and D here, as you can see here, actually it says that okay, it is true because CD is in the list. Okay. Same thing for the E and F. Okay, basically the E is not there, but F is in there. Okay. So let's take this one as an example here, right? Obviously this problem it's a try problem. Basically, it's a prefix tree problem, but it's a little bit different comparing with the traditional prefix tree because because here, right? Because here we need to find the previous like the words starting from the last one. Okay, because in this case, let's say if we construct the prefix tree with the original order here, like C, D, F, and KL. Okay, if we construct the tree in the normal way, and when we are trying to loop through the each letter here, right? I mean, since so basically we don't know which where's our starting point, right? Because let's say when we have D here, obviously we need to store a list of the letters we have been typing here, right? Basically, obviously we're gonna need like self like a stream, right? The stream here. So here where it's gonna be like a list of the string here. But if we're storing the construct the prefix tree in the normal way, I mean there's no starting point for us, right? Because we don't know which is the starting point. But if we try to reverse, if we try to reverse each word, okay, and basically when we construct the prefix tree, instead of C, let's say there's a root here, right? There's a root, and then there's a C and D, right? Okay, instead of constructing this way, right? All we need to do is we just need to reverse the construction. Basically, we have D here and C here first, and then F is the same, okay, and then here we have a L and K. Basically, what it means that if we construct the words in a reverse order, so all we need to do now, see now we can just starting from the latest letter, and we keep going back, okay, as long as we find a word, right, then we know, okay, we can return true. Otherwise, as long as there's a false there somewhere here, or in on the way, we simply return false. Yeah, basically that's the only difference. This problem, why this problem is a little bit tricky, because it asks us to reverse the order of each letter when we add each word into the prefix tree, so that it can be aligned with the with this letter stream here. Okay. Uh, cool. So now let me try to code this class. So the code is gonna be a little bit uh, too much, but just stay with me. Bear with me. Okay. We can have a tree node here. You know, just a regular like a template, right? Of the try. Okay, basically, and when we create the node here, right, we're gonna have a self and we'll have a value, right? So and have self value equals to value and self dot children, right? That's how we construct the node. Basically, each node is not besides its value itself, it also have like a dictionary, a hash map of its children. And now we also have like its word. Okay, cool. So that's the tree node. Now, I mean, uh, we just need to define like a few helper functions because we need the add, right, for the to build the try. So we have a add self dot word, right, and then we have another one, okay, find, right, find self. Okay, cool. So let's try to build this tree here. Hmm. I mean, like I said, right? So we'll have like a root here. So in the root equals to what? We're gonna have like a tree node at 0. Okay. The value here doesn't really matter. We just need like a root here. Now, now let's try to build this try here. Basically, for each word, right, in the mm, in the words, right, we call this. We do a self dot add word. Okay. And like I said, we're going to be we need to reverse the order. We need to reverse the order here. So we have a current, right? Current equals to self dot root, right? And then for mm, for character, right? In word, I'm gonna reverse it. Okay, that's how we reverse the word here. Okay, mm, current. So if C not in current dot children, right? If C is not in there, we do a current dot children dot uh, C equals to the tree node. Okay. Tree node C, right? Yeah. So we have a value, then we have a actually, you know what? Actually, we don't for in this case, we don't need the value here, you know, to build the tree node. Uh, the key in the children is our is the key. I mean, the value here, I mean, unless we want to store something else, right? Then we need like the value here. Like for example, if we want to consider like the counts of each word, then probably we need like another property here. But in this case, we don't need that. All we need is the children and its word property here. so that here we can just remove that, and also here, okay? And then we're gonna have like current, let's continue, equals to current dot children dot c, okay? And in the end, we simply mark this last one to the is a word to true, okay? Because that's the last word, okay? Yeah, and we keep going, right, until we have loops through all the word here. Now the find, okay? So the find is pretty straightforward. Basically, we also need to have current equals to self. We always start from the root, right? And then we also need like mm, oh yeah. So in our case, the find doesn't have a parameters because uh, the find string will always be stored in this self dot string. Basically, it's gonna be a B, C, D, right? Either A and B, or whenever the current stream we have stored in the stream here. Okay, so and like I said, since we're going to create from the last one to the first one. Okay, then uh, we just need to for I in range, let's do a length of self dot stream. Okay, and minus one. Okay, minus one dot minus one dot minus one. Right. That's how we reverse traversing this string here. And we simply do this. Basically, uh, character equals to self dot stream equals to I. If C is not in current dot children, okay, we simply return false. Okay. And if it's in there and we update that, we update current to the current dot children dot C. Okay. And in the end, we return like current uh, uh, actually no, actually here we cannot wait until it's done, because in this case it's gonna DCBA. It's not when we reach the A here, DCBA is not one of the word, right? Basically we cannot return from here. It's a DC on its way. There's like a valid words on its way. So here I think, yeah, so whenever we have a new current here, we just need to check if the current is a word. Okay, if current is a word, then we simply return true. Okay, otherwise I think here we can simply return false here since we didn't find it. Yeah, that's how we loop through this string here, stream. We start from the last one, and then we go back. We try to see if there's a word uh, in on our way of traversing back, then we simply return true, and we can simply stop. Okay. Uh, yeah, and I think we have pretty much done everything. The only thing left here is that every time we have a query, first thing we need to do is we just need to append the letter, right? The letter to the stream, and then we simply return find. Okay. Yeah, I think that's pretty much it is. Let's try to run it. Oh, sorry. Self dot find. It's a class level method. Yeah, accepted. Submit. Cool. So yeah, successful. So you know, it's not this problem is it's not that hard. It's just like another a small variation from the original try prefix tree template, I think it's worth uh, uh, talking about because this can help you get more familiar with this try structure, right? I mean, you build the try here, but in this case, right, so we have to store the words in a reverse order so that we can we can start from the last one and traverse back. Otherwise, right, we cannot search because we don't know where we should start. Okay. Um, yeah, I think that's pretty much it is for this problem. Yeah, I hope you guys like this video and yeah, thank you so much for watching it and stay tuned, guys. See you soon. Bye bye.